Alright, this video is going to talk about how to solve quadratic equations using what we call the quadratic formula. We want to remind you of a couple of things beforehand and kind of give you a reason why we need the quadratic formula. It's going to be our third method we've learned how to solve quadratic equations with. So why do we need it? Well, the first thing we want to remember is that roots of an equation are the same thing as the x-intercepts. Now, we've found those very well when we factored. Remember, intercept form and factored form, very similar. So factoring is very, very good. But you'll also remember that not everything is factorable. So it's not a perfect method, which is why we need other methods. It'll also help you find the zeros of an equation, or the solutions when y equals 0, such as the two equations down here at the bottom. If we subtract 11 and divide by 25, and then we take the square root on both sides, don't forget your plus or minus, we'll end up with a couple of good answers there. Same thing goes on the equation on the right. If we wanted to, we could subtract 11, divide by 6, now we need to get rid of that exponent before we can deal with that 4. So I'm going to square root both sides. And on the left, leaving it with x plus 4. On the right, plus or minus root 3. And then we'll subtract our 4 after that. Negative 4 plus root 3 is a negative 2.268. Negative 4 minus root 3, negative 5.732. The nice part about both of those equations is they solve very simply using, again, what we called square roots. We could just sort of solve for the x, because there was only one x available at the start. There was only one x to solve for at the beginning. The problem with most quadratic equations, or many quadratic equations, is they have an x squared and an x to the first. Now again, that's where oftentimes we'd say, okay, well, let's factor. Let's solve and get this thing equal to 0. Right? So we could do that, and then we would approach it from there. Well, that idea of getting it equal to 0 is still going to be helpful today, only we're going to take a little bit of a different approach. We're going to use what's called, again, the quadratic formula. It's this formula over here at the left. So again, if you have a quadratic equation, notice it needs to be equal to 0. Standard form equal to 0. We've got ax squared plus bx plus c, and again, we're equal to 0. Then we can identify a, b, and c, and we can plug them into this large formula in the red box. This larger formula down here. And the formula goes a little bit something like this. If you want to memorize it, you can actually put it to the tune Pop Goes the Weasel. So let's hope I'm on tune today. But if you want to sing it to yourself, it goes a little something like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You got to hit that high note on the all. Just reminding ourselves that everything on the top is divided by 2a on the bottom. Now, we might recognize part of this formula. We talked about the discriminant yesterday. b squared minus 4ac, remember, was the discriminant, which told us, again, if you're taking the square root of the discriminant of b squared minus 4ac, if b squared minus 4ac is positive, we're going to get 2 plus or minus real answers. If it's negative, we won't get any real answers. And finally, if it's exactly 0, we'll get one real solution. So let's see the quadratic formula unfold here. Then maybe we'll go practice it a couple of times. So the first thing, like we said, we need to do is identify a, b, and c. So remember that a is the coefficient of x squared. So we've got, for us, a equal to positive 1. b is the coefficient of x in the middle. So we've got b equals 6. And c, remember, is your constant. So c equals 8. Because we were in standard form equal to 0, we can identify those parts. Now let's plug them into the formula. So what we're going to say is x equals, notice we're going right to the answers. X is equal to, we're almost done. Only we have a pretty hefty formula to set up. Negative b, so negative 6 plus or minus the square root of b squared, or 6 squared, minus 4 times a times c. And again, plugging in all those values. All over 2a, so 2 times 1 on the bottom. Now, like I said, we're already solved for x. We're actually solved. What we need to do, though, is clean up this large statement we have here at the right. So let's start by rewriting negative 6 plus or minus the square root of, Now let's find the discriminant. Again, 6 squared would be 36, minus 4 times 8 would have been 32, and 36 minus 32, if you plug that whole thing in your calculator, should come out to 4. And again, we're still over 2 times 1. We can simplify that a little bit. Let's just call it 2. Well, the square root of 4 is kind of a nice number. So we should go there next. We need to deal with that square root before we can add or subtract. And we need to add or subtract before we can divide, because it's this big fraction, right? Everything on the top needs to happen first before we get to divide. Well, we have negative 6 plus or minus the square root of 4 would have been 2, all over 2. And now we need to split it into 2 parts, because we need to handle negative 6 plus 2 would be negative 4, or negative 6 minus 2 would have been negative 8. And again, still all over 2 on the bottom. Well, in that case, negative 4 over 2 is negative 2, or negative 8 over 2 is negative 4. And we've got our 2 solutions. I'll guarantee you, if you plug negative 2 into your original equation up here, negative 2 squared is 4, plus 6 times negative 2 would be negative 12, and 4 plus negative 12 is negative 8. Feel free, you can check that negative 4 for yourself. Plug that in, see if it isn't the solution to your equation. Now, this does look like a lot of work, but the nice part is the quadratic formula isn't really held back. Some things aren't factorable with nice round whole numbers. So when the answers don't come out nice and clean, if they're fractional or if they're decimals, well, a lot of times factoring just doesn't work. Or even worse, if they're irrational. If this square root, right, in here, instead of being the square root of 4, was something more like square root of 5, I can guarantee you something wouldn't have been factorable then. Solving by square roots doesn't always work. As we already talked about, you might have an x squared, but you might also have an x here. Well, I can't solve this one by square roots, or the method of square roots, because there's no way to get x squared and x together, and there's also no way to get them separately, sort of split apart like we do in factoring, to where I can solve for just x all by itself. Quadratic formula is a really, really helpful method. But yes, the downside is it is a little bit of work. So let's go try it out a couple of times. Let's see how this works. Oops, a little too far there. So taking a look at our screen here, we've got 3 different quadratic formula problems on the screen. Notice all of them are equal to 0, so we're ready to go. The first thing that I would do with each and every one of them is identify A, B, and C. So as we go through the problems here, feel free to pause as we go along. Try to get ahead of the game, see what I'm about to say next, and see if your answers match up with mine. So again, the first thing I'm going to do is identify A, B, and C. Hopefully your numbers match up with what I said. Now let's take our A, B, and C and let's plug them into the quadratic formula. So again, the formula says negative B, right? 12 makes it negative 12, plus or minus the square root of b squared minus 4ac, a being 9, c being 4, all over 2a, right? 2 times 9 being 18. Let's set up the other two as well. So again, negative of b being negative 5, so that's going to turn out to positive 5. B squared, and don't forget your parentheses, we want to make sure that when we square that, we end up with a positive 25, minus 4 times a times c, all over 2a. And the same thing goes over here. Negative of negative 4, plus or minus the square root of b squared, negative 4 squared, minus 4ac, all over 2a. Now it's just a matter of simplifying. Let's find the discriminant and clean up the bottom. Find the discriminant, clean up the bottom, and find the discriminant and clean up the bottom. Well, if the discriminant is 0, the square root of 0 is 0. So negative 12 plus or minus 0 is still negative 12. And we just get a negative 2/3. Note one solution because, again, 0 under the root. Positive 65 should have 2 solutions. Unfortunately, root 65 is not a nice number. But that's not going to stop us. We can still split this into 2 parts. And if our book wanted us to find the exact values, I would stop there. In fact, I would have even stopped one step earlier. Because square root of 65 is exact, We haven't rounded anything. That would be an exact value answer. If you want the decimal values, though, again, split it up. We got a positive, we've got a negative, and now we need to type carefully. Remember that when you're typing these in, you need to make sure that the entire top happens before we divide by 2. We got to make sure we subtract before we divide by 2. But again, if you do type those in, here are the answers you should come back. And on the final one, notice the square root of -8, which immediately just tells us don't work so hard. There are no real solutions. I hope that helps you with the quadratic formula. A couple of things that we can do with the quadratic formula would be to find roots of an equation. Just like we've been doing, we've been finding solutions or roots to equations. We can also find, again, the zeros of a function. If it's y equals our function, we can find the zeros or the x-intercepts by plugging in 0 for y over here, then plugging it into the quadratic formula. So take a second. Again, I'm going to pause the video now. I'm going to fill in the quadratic formula. Go ahead and check your answer afterward, and then you'll be able to start your homework. All right, and we're back. There's a whole lot of writing on the screen, so here we go. We've got our equation here. Now notice the first thing that I did was I had to subtract 30 over to the other side. So 7 minus 30 became -23. Again, that means that a is 2 in front of x squared. C, notice there's no x here, so -23 was our c value. Since there's no middle term, there's no x to the first term, that means that b equals 0. So I plugged all my numbers in, -b plus or minus b squared minus 4ac all over 2a. Working out the discriminant, I got 184. Because -0 doesn't really need to be there, I just went ahead and didn't write that. And on the bottom we've got a 4. The square root of 184 is not a pretty number, but it's 13.5647. And if I divide that by 4, I'll get a 3.391. Again, your final answer rounded to 3 decimal places accurately. So notice up here I rounded to 4 because I wasn't done yet. I want to divide and then I want to round off to be accurate. But notice that plus or minus. Again, we've still got 2 answers because it's built into the formula now. We're going to get that plus or minus. Over here at the right, again, we plug 0 in for y. That means that a is 15, b was -5, and there wasn't a constant, so c is 0. So notice c plugged in as 0 into our discriminant here. I went ahead and simplified the numbers. The discriminant was -35, which immediately told me that there are no real zeros, there are no x-intercepts. This graph would never cross the x-axis. All right, I hope that helps you use the quadratic formula. Again, in your homework tonight, make sure you're writing out all your steps. Write down the full formula. Simplify a little bit. Find that discriminant before you go finding your final answers. Have a great day, and happy parabolas.